Alright guys, so we have come to this third topic, which is literal equations. So literal equations are kind of weird math problems where we have to work with mostly letters, variables, but not hardly any numbers, right? So what I wanted to do first for this was to show you some of the algebraic properties that we use to solve equations. One of the main ones that you have seen is that this property where if you have a and you want to get rid of that a, you multiply by the you multiply by the inverse of a, which is 1 over a. So that ends up being just 1. Okay, so the a is gone and I'm left with 1. And then the other property that we have is if you have a and you want to get rid of the a, you can add the inverse, which is the opposite, and then that gives you a 0. Okay, so basically these are the properties. So if you're dealing with either multiplication or division, you use this property where you try to get a 1, and then if it's addition or subtraction, you use this property where you try to get a 0. Okay, so I'm just going to keep that handy. Hopefully you're able to kind of see those properties in this. Okay, so here for each problem, it's going to tell you what to solve for. For this one, it's asking you to solve for t. Find t is right there. I need to get t by itself and remove everything. Now I have to look at this very carefully and see that t is being multiplied. Okay, t is being multiplied. So which means that I need to get rid of the PR. So to get rid of it, I have to basically multiply by the inverse, or in other words, just divide it out. I could either look at it like this, multiply by its inverse, which would be 1 over PR. Okay, whatever you do to one side, you have to do to the other side. And so see what happens here. The PR and the TR, they're gone. You just have the 1. And then 1 times t is just t by itself. And then you're left with all of this. You can kind of simplify this. 1 times I is I over PR. And I have t by itself. That's my answer. So t equals I over PR. Okay? We can write it like this, or we can move the t out in the front. Just erase it over here. So you have t equals I over PR. Alright, so what about here? See some addition, but let's see here. I have a y. I got to get y by itself, so I have to remove everything else. So what I'm going to do is I'm going to remove the ax. So in order for me to remove the ax, I need to add the inverse to both sides. So if I were to add the inverse of ax, it would be negative ax. So I'm going to put negative ax on both sides. What that allows me to do is just gets it out. Then you have just a 0, and a 0 plus anything is itself. So you just have by equals, I have c minus ax. And then from here, I'm not done yet because I only want b by itself. So now I see it's being multiplied here. So I can do that whole, multiply both sides by the inverse, which is just 1 over b. 1 over b. We have to be careful here. We have to make sure to multiply everything by 1 over b. I am so sorry, y'all. There you go. I keep doing that. Okay, so now what happens here is the b's get canceled out, so you just have 1, and then 1 times y is just your y. And then here, the way we kind of write this, either we can distribute that out, or we can just go ahead and just stick it under the whole thing like that. B. Okay, so that's that. Here's a couple more. So I have p here on the inside. So that's what I'm solving for. So what I can do here is I can multiply, I can get rid of the 4 over 3 by multiplying by the inverse of 4 over 3, which is just basically the reciprocal, which is 3 over 4. And we're allowed to do this as long as we do it to both sides. Whatever is done to one side, you got to do it to the other side. So what happens here is all of that becomes 1, and then 1 times whatever I have is itself. So P minus Q. And then over here, I just have 3 over 4R equals PR. Okay, I'm not done yet. I still have to solve for P here. Okay, so to solve for P, I need to remove this. So again, if I want to remove it, I have to add the inverse on both sides. So if I do plus Q on both sides, then that allows me to get that out, which is 0, and then 0 plus P is just P by itself. And then I have all of that. Let me go ahead and just write it on the other side here. And then so that's Q plus 3 over 4R. Or you could say P equals 3 over 4R plus Q. Both are the same thing. Alright, last one. B over B1. That's what I'm solving for. So I'm going to multiply both sides by the inverse, which is 2 over 1, which is just equal to 2. 2 over 1 is just 2. So I have here 2A equals, and then just all of this goes out to be just that 1, and then we just have this remaining. Okay? And then from here we can solve for B. So again, to get rid of the B2, I need to add the inverse, which is negative B. So I'm going to add the inverse. So that gets rid of that. So you have B1 equals, just put those two together. So either you can put negative B squared, not B squared, B2 plus 2A, or you can, have them switched around. Like that. Or you could switch them by doing 2A minus B2. That's that.